Welcome to a new video in my Home Automation, OpenHab and Node-RED series. If you remember a couple of months ago, I did a video on how to work with time series data, how to do store values from different sensors in an SQL Array database, and how to use the dashboard to view this information. And I have done a chart where I can dynamically generate data out of these store values, and it can display it in a nice chart in dashboard. But that chart, if you remember, it actually was this one. It was okay, but it wasn't really the nicest one. The user interface wasn't really good because you had to remember to select both the data sources and the periods in order for the chart to work. And then whenever the chart got generated, the selection got removed, because this is just the way these dashboard components work. But I've managed to work on that, and I have a newer version of that, which I think it works much better. And then the user interface is also quite nicer, and the features that are provided are probably a little bit more user-friendly than the previous version. So in this video, I'm going to talk about that and some other display options of data in general, which I'm going to cover also in this video. So let's get started. And as usual, the link to the code is available in the video description. So let's get started. First case, I want to recap on the way I'm storing the information. If you need more details, go back to my previous video. You can find the link to it in the cards in the upper right corner. And but just want to recap on the data structure again. So I've created two tables. One is the sensor underscore data, where I'm storing the incoming values. So let's say every 15 seconds or every 1 minute, depending on how I set up the various sensors. And I do have also some logic which creates some aggregated information, like here the maximum of the day, the minimum of the day, the last value of the day. And both of the tables look fairly similar. So in the sensor data, I have a device field and a sensor field, and the value and the epoch in the Linux time format. So I always reference to a particular value with a device and a sensor pair, and the value is being in the value field. So in the Aggregate database, the database looks quite similar. So I have a device field, which would be the same as the device in the data table, and also a sensor field, which is again similar. So it says, let's say it's the same sensor name as in the data table, with underscore max, which would say that, okay, this is the max value for that sensor for the day. I mean, I'm usually doing aggregations by the day, but again, you can do it by week or month or whatever. So referring to this data, to these tables, are going to be fairly simple. And if you look at the functionality, actually the dashboard, I made it a little bit too big, so I need to reduce my resolution. Otherwise, I can't fit the whole thing on the screen. So the look and feel is fairly similar. You get the main chart area, and then on the bottom I have some filters. And on the top I also have a label, so I can actually see what I'm displaying. So it shows me the data values or the data series and the time, and so the time window. So what I have done is, instead of you having that checkbox kind of thing in the previous version, which was on the side, I have drop downs to select the data source. And if I select the data source, that data source is being added to the chart. So now the chart is being regenerated with the solar panel voltage added as well. I mean, it's so low that you can't really see it, but if I hover over, you can see that it's actually there. So that's the problem with, I don't really have nice data in my system, because I have values that are so vastly different. So if I, for example, add this sunlight, which is going from the Mi Flora plant sensor, I mean, that values is up in the the couple of 10,000. So it basically just makes all the values look really small. But if you want to get rid of it, what you do is, on the top you have this remove all, which resets your resets the chart, so it removes all the data or data series from the list. So you can just start adding back together. So I can add the temperature back, so now I can see the temperature. And by the way, you can also select the time frame. So if I only want today, or if I want the last 24 hours, or let's say the last 7 days. And I also have some buttons here, so I can easily move back by 1 day. So you can see that the chart moves to the right, and it goes the other way, and I can also skip by weeks as well. So I thought that would be much easier than doing it in the as I did in the previous one. And one more feature which I've added is not only that I can select my normal data series, I can also select my aggregate series. So so this is now showing the temperatures, and I can put the temperature max on top of it, and that data is only like once a day, but the chart can cope with it quite nicely, because you can see this second line which only has values like 7 values within this time period. Of course, the problem is that the time I put on the timestamp I put against the maximum value. Actually, I put the how do I do it? I put the date like 0 hours 0 minutes of the day, so it's not actually the time when it was the maximum temperature, which means that this data point doesn't line up perfectly with this one. So the stats max was 27.1, which is actually probably here, yeah. But I guess you get the point. The whole thing is that the code and the chart doesn't really care where the data is coming from. It can mesh these different data sources together, and then the chart just displays as it is. You just need to supply the values and the time. So the time and the so basically the time data and the value, and it can take care of it, and it will display it. And you can keep adding. So temperature, what can I add to temperature which is not going to skew the data? Maybe I can add the battery level, which is going to be a flat line. Oh, maybe I don't have battery level. Then let me see, voltage, power. Anyway, it's all going to go haywire now. Yeah, oh, now we have battery as well. So I have to say it works quite decent, and you can work with whatever the standard stuff provides you. My Pi was done, or maybe my so I had some issues with the system and with my Raspberry Pi, and this is why if I go back in time, sometimes I don't have sufficient data, and that's why the chart looks a little bit weird, but it actually works. I mean, I know it works quite well. So this one on the top of the screen, that's my old code, which I still have it here, but I'm not using it anymore. And that's the piece which is responsible for the new chart. And it's mostly the UI elements. Otherwise, the flow is pretty much the same. So you put the SQL statements together, you pass it over to the DB component, you join them together because you need, well, at least I do separate SQLs for each of the data series. And in a function node, I reformat it in a way that it can be represented in a chart, or the chart understands it. But going back to the buttons, I have what I have done is every time you click a button, so in the screen, every time you click a button or select a drop down or do something else, then the information goes back to goes into this SQL node. And then all of it basically goes into the SQL node, and then that is decides what I need to do in order to perform the function behind that particular UI element. So you have the stuff here which does like -1 week, and what I have done is every single button or every single UI element have a different topic. So this is -1W, -1D, +1W, and +1D. So that's going forward and backward by 1 day or 1 week. And then I have the data source, which it looks exactly similar, well, very similar to the one I've done previously. So I have a again, this has a particular topic which is called the data source, and the values are obviously there is a text value, but the actual value is always the same device slash sensor pair. That this is the way I store it in the database as well. And on top of it, there is this top entry, which is the which removes all the items from the list or from the chart, and it has a value of delete. So I'm going to handle it separately in the code. And then I copy this to the aggregate data source, which has again the similar values and descriptions. It has the delete all, and then it has all the values and values being formatted as device slash sensor. Oops, sensor pair. I probably should not save this one. Let's go back. Yeah, fine. And the difference here is again, it has a different topic. So in the code later on, I would know whether I've selected a normal data source or an aggregate data source. And probably you can use the same logic to differentiate if you have separate tables and you want to mix and match data from different tables. And just like before, we have a period dropdown to select the default time base. So again, it can be quite a few default predefined ones, like today, yesterday, this week, last 24 hours, blah blah blah. And again, this has a particular topic which is called the period. So all this information goes into this SQL function node. Just again, for somebody who hasn't used this dropdown, so let's say if I select today with this dropdown, then I will get a message which has the topic of period, and it has a payload of today. And that's what I'm going to do. What I would try to understand here in this function node. So on the top, I'm just declaring a bunch of variables. Like this is like 30-day period, 7-day period, 1-day period. I'm getting the current time. I'm calculating the today 0 hour time, and what's the Monday 0 hour of the current day. And I'm creating also a few local variables, arrays, and some other stuff which I'm going to be using later. Going back to these variables, so in the what I will use this source list array for is I will collect everything which I selected here. So if I click on temperature, then I get the temperature displayed. But in this array, I'm actually storing that now I'm displaying the temperature. If I select the battery level again, then this array would have like two entries in it. One is the which actually you can see here in the tooltip, is the meflora / temp and the meflora / battery. And because well, you need to remember this in order to make this add and remove functionality working. I'm creating this these variables, and then you can see later on that these variables will get stored in the context. And I think this is the first example I'm starting using context instead of the global, because every single message which has to do about refreshing or changing the screen goes through this single function node, so I can just store the information within the context of it. I don't really have to go store it in the global, which probably makes it a little bit neater in terms of how data is stored. And what I'm doing in the beginning of the code, I'm just restoring these variables which were saved in a later session. So the source list equals context.get source list, and if it's undefined, so if undefined means that I'm running this code for the first time, or the first time after the pi got reset or NordGet got restarted, setting it to an empty array. The same for the aggregate list. And also I'm storing the end date. Oh, sorry, yeah, a from date and the end date, which I calculate from the period. Oops, sorry, from this period drop down. So that's mostly a housekeeping. And then there is this whole switch case section where I see, okay, what is the message that I got? So if I got a period message, that means that I've selected something from the period dropdown, and then I start evaluating all the different cases. And basically all I'm doing is I'm setting the from date and the end date depending on the values. So if it's today, then the from date is today 0 hour plus today 0 hour plus 1 day. That's the value for a 1 day period. If it's yesterday, I do it. It's all straightforward. Like yesterday is today 0 hours minus 1 day, and the end date is today 0 hour. This week, last week, last 24 hours. Last 7 days, last 30 days. So it's nothing really complex here. And once I've calculated this from date and the end date, I'm also saving them in the context, so it becomes available next time the execution comes here. Next big case is the source list. So again, if I picked a new data set from here or data source from here, which I want to add to the chart, then the execution comes here. I'm doing this special case, so if the payload is delete, which means that I have picked this remove all button or the remove all option, that I'm setting the source list to the initial value, which is an empty array. And otherwise all I'm doing is I am adding well, first I'm getting the source list as well, which probably it's not needed anymore because I have just done it above. But anyway, if it's not delete, that means I've picked a valid data source that I want to add to the chart. So I'm basically just adding this value into the source list array. So source list pushed and the message payload. And again, I've updated the array, so I'm saving it in the context so it becomes available next time. And I do exactly the same for the aggregate source. Instead of using the source list array, I'm using variable, I'm using the aggregate list variable. So I haven't started constructing any of the URLs. I'm just storing the fact that I made a change on the UI by selecting something from the dropdowns. And that's the code where I click on these buttons. So -1 week, -1 day, +1 day, +1 week. And because I have the from date and the end date restored from a previous session up here, right here, I can just easily, subtract. Let's say if it's a -1 week, I just subtract 7 days from each of them, and that becomes the new context. So I'm saving them immediately in the context again, and the same for +1 week and -1 day and +1 day. So I think it's fairly straightforward. So by the time we come here in the code, we will have our data source list and the dates updated if they needed to be updated. So what I can do here is I can start generating the SQL statements, which would be required to get the data and eventually display that data on the chart. And that one is fairly similar from the previous example. I'm using this SQL array just to store all the SQL statements, and I do source list. I'm checking whether I have anything in the source list. And if it's more than 0, then I'm just looping through the values and I'm generating the SQL statement. So let's say, and in my case, it's always select start from sensor underscore data, where the device and the device is parts 0, and then the sensor is parts 1, and all the parts come from here. So the source list array again is storing the data source in device / sensor pair as a string. So all I'm doing is splitting this string up to basically two strings using the slash. So the first one is always the device, the second one is always the sensor, and I also add the from date and the end date to the select statement to limit the data which is coming back. So this is how I can just say that I want today's data or this week's or last week or whatever. And if I also need to add anything from the aggregate list, I'm doing pretty much the same piece of code. Again, it's a different table name, but otherwise it's the same because that table has the very same fields that I want to filter on. So if you would have, if you have a setup where you have the data stored in different tables, you can modify this piece of code to execute different SQL statements based on the data that you want to display. Maybe your device is the table name, so you can put the device name here instead of being as a fixed value in the select statement, or whatever that you need to do. This code here, or that few lines here, it's checking if I have any SQL statements generated, and that would be true. So if the SQL length is 0, which means that I don't have any SQL statements, so that's the case where I have removal here and I have removal here, so I don't have any data sources, and I needed to make some select statements up, because otherwise I would be putting some invalid statements to the SQL node, and I will getting all sorts of error messages. So here I'm just made up this select statement, which I know it's not going to generate any valid records, but at least it's going to satisfy the later on logic, and it's not going to throw all sorts of errors because the data which is coming is not in the expected format. So this is just a dummy select. But at least it has to be a select which refers to a table that you have in your database, in case you are using a different data structure. And just like in the previous example, if I go out, now this SQL node is going to generate multiple SQL statements, and those will be sent out at different as different messages. So this database is going to again generate multiple messages for each of the sensors in my case, or each of the data sources. And for that I'm using this join one to join them together, so I can just process them together. And this join has a functionality here, is it will wait until it receives a message which has the complete flag set. And oops, sorry, and that's what I am doing here. Where is it? Yeah. So I'm just setting the last one, the last message.complete equals true. So that join will actually trigger, and it's not going to wait forever for the last message. And you can ignore this one. I was trying to do some additional functionality which didn't actually work. So this piece is not being used. I mean, you can leave it here. It's not going to have any impact. And the last step in the logic is I generate the title of the report. So all I'm doing is basically this one. So I'm just concatenating all the data sources together, and then a pipe, and the from date, the from date and the end date formatted as a day, month, year. So actually, without looking at the series and then going into the chart to look at the legend, I can just scroll up here and then can see what's being displayed in the chart. So that is being constructed here, and I'm putting everything into like a title, and I'm passing that title onto the last message, so I can collect it later on. And then I will pass the SQL array into the output, which again, is being an array, is going to generate multiple messages at the end, or actually here. So all the SQLs go into the DB node, and they get joined together. And here I'm just separating the title. I'm putting the title into the payload, and I'm passing it over to a text node, which is this text node up here. So the title gets updated whenever a chart is updated. And I have this piece of code which reformats the data into the format that is acceptable by the chart. And that one is exactly the same as in the previous example. I'm just thinking if I have made any changes to it, but no, actually not. I've even left the commented outlines without any changes. Okay, now I modified the flow just a little bit to put 3 debug nodes here, so we can see all the SQL statements going out from the SQL function node, and then we can see the data being returned by the database with this one, and then how it got reformatted by this final function node, which is acceptable for the chart. So let me come here and then maybe change the time base by last week. Okay, that's fine. So now we only have one data series. And yes, so this is the first one. So that's the select statement. And I put the debug note so it shows the entire message. And first of all, you can see that it has a topic. So select start from data sensor data where the device is this and the sensor is that. And the date is between these two dates. And you can see this complete flag. So that's for this join to make sure that it finishes and doesn't wait for any further messages. And the title, which gets separated here. And yeah, message ID, we don't care about that. So let's see how the data looks like when it comes out of the function node after the join. And again, we'll still have the same select statement from in the topic. We have the title, which again goes here, and the payload is now the database select, or the data returned by the database, and it looks like this. So you have a key, which is the sensor data, and then you have the values. So the values property is again an array which contains each of the data points which are being displayed in the chart, so each of the stuff here, and this has this particular format which is like this. So it's an array of 500 data points, and in each data point is actually an array where the first one is the time and the second one is the value. So time value, time value. Okay. Oh, sorry, wrong one. I was doing it the other way around. So sorry, this is the one which comes out of the join. Yeah, because I know that. So here the topic, the title is exactly the same, and then you have the payload, which is again it's an array of 528 items, which are the 528 records returned by the select statement. And this again, if we look into the array, in the array, or in each item in the array is an object where you see each of the values from the database table. So yeah, I mean, this is how it looks whenever you use an SQL statement. That's how the data is being returned. And again, it gets reformatted here. Let me close this one. There's too many stuff here. So it gets reformatted here, and that's the format which is expected by the chart. So you have I have an array of 1 because I only have one data series, and the array item is an object. It has a key, which is the name of the data series. So this is why it's here in the tooltip. It's the label gets displayed like me flora / temp, and the value. Sorry again, too much clicking. Where we are, yeah, here. So you need an object which the key is the name of the data series, and then the value is the array with all the values, and each item in the array is again like a two-dimensional array where the first value is, or the first number is the X value, the second is the Y value on the chart. And if you go into the into the code which does that, you can actually see that we have the two loops. So this loop is going to the outer loop is going to loop through the multiple data series if you have multiple data sources selected, and the second one loops through one individual one. And as you can see, it's creating these pairs of 0, or the first one. So this two-dimensional array is where the first value is being the epoch, so the date, and the second one is being the value. And then once all these values are collected, so in this case it's 528, then it creates this object where the key is, I've put the key again as a concatenation of the device/sensor value, and the values here is the output which got generated in this loop here. So again, if you have a different data structure where you have different tables, the data is coming from different tables, then again, just remember that here, this is the piece, or that's actually the field name where your data is stored. That's the field name where your value is stored, and here how you generate the name of the data source. So that's the 3 pieces of code that you would need to change if you have a different data structure. Okay, great. Let's delete the debug and add another data source. So I'm going to add whatever, power. Okay, so the chart got updated. That's nice. And we have also the new stuff. So the first one, this is the first message. Okay, so actually, so these messages are coming in a different order. Okay, so these first two, this first one and the second one come from this SQL statement. And as I said before, now we have 2 data sources, so this code actually creates 2 different messages. So the first message is to get the temperature, and the second one is to get the power. So it's just SQL statement, and as you can see, the last one contains the complete flag and also contains the title. Now you can see that the title contains both of the data sources, or the name of them. And then we come here. So this last one again is the data which is coming out of the join, and you do payload. Oh, okay. First of all, you can see that now it's an array 2, because we have one array which contains all the temperature data, the second array contains all the power data, and again they have different values. We don't really care about it, the chart will take care of it. And then the data format itself is the same. So you see the structure of the record database. If I look at the other one, because I have the same the information is coming from the same table, is going to look exactly the same, so it has the same values. And finally, that's how the last one got generated. And now you can see that the payload contains an array, but now the array has 2 values, because we have 2 data series. And if I expand them, so now you have the first one is exactly the same as before. So the key is the temperature, the values are the 528 values, and now the second one is the power, and again we have 1113 values, but the data it's inside looks exactly the same. So again, each data point is a 2-dimensional array, X and Y values, and the same here, X and Y values. So that's how you do it. I mean, if you understand how this looks like, well, now you can see how this looks like. As long as you can modify this code to create the same sort of data structure, your chart is going to work. The last thing I did on the data visualization side, besides creating this new report, is which I call the KPI. I mean, it's probably not really KPI as in key performance indicator, but it's it just looks similar how the KPIs in in one of the software I'm working with is displayed. And it actually made me think, because sometimes you display the current value of any sensor. In some cases it makes sense, but in some cases it's hard to put into a context. And charts usually take up a lot of space, so you can't put charts on everything because then it would be just overwhelming. So I was thinking about making these small tiles where you display a particular information, but or a particular value of a sensor, or like an aggregated value of the sensor. But again, next to it, you try to put it into context, saying that okay, let's look at the generation from my solar system. So it did 217 kilowatt hours in the last 30 days, and that's up since the previous 30 days by 175 kilowatt hours, which is not surprising because we are going into summer, so we have a lot more sunlight. So again, it's the concept of how you can, what is the best way of understanding your data. Even if you can't really, if you just see 2017, it might be, it could be a little bit hard to put into context, but you can see that it's like almost doubled. Then it makes more sense to understand what's going on. Or if I take this one as a case where it's again the solar generation, but it's only the last 7 days. So yeah, I have a figures of 46.3 kilowatt hours, but I can see it's down by 51%. So again, I'm showing a value, I'm showing a trend, but instead of like a number of increase, I'm formatting that change in a percentage wise. Again, the reason for this, because we have some bad weather in the last in the last week. So there's a lot more cloud as it was a week ago, which again makes sense, but it's probably easier to put this into perspective. And then I was also thinking about a third way of doing all the same thing, which is similar to this one, but instead of having an up and a down arrow and having a percentage one, there is this progress bar, which shows that percentage in a more visual way. So I have the solar generation today, which is, well, actually it's not updated because I update this manually, but it was 15.3, which is 76% of yesterday's generation. So that tells me that today is a little bit more cloudy than it was yesterday. So the way I separated them out is put all of these templates into a different group. So the first one is this group, and I defined a group that it only is like 4 units wide, and the tile itself is only 4 by 3. So this is how I try to limit the size of it and make it appear reasonably aligned, even though that these first two are aligned, but this third one is not really, because this is taking a little bit more space, so it's pushing the main digit a little bit up. And the reason I use separate tabs, because now each of them has a little bit of border. Otherwise, if I would have put it into one group, then it would be just in a one big white background. But again, it depends on how you want to use it. But let's look at the code, because that's a little bit more interesting. So at the moment I'm triggering this manually, but normally you would set it up to update once a day or every 15 minutes, whatever. It depends on the application and the data that you are trying to display. And in the SQL statement, there is quite a bit of a code, but most of it is just calculating dates and times. But the main thing is I am generating 2 SQL statements, and the first one is to calculate this big value, and the second one is to calculate the lower value. So as you can see, each of them is displaying a value with relation to another value, which is like the current 30 days and the past 30 days. So to get those 2 values, I'm generating 2 SQL statements. So the first one is again, if I'm using the my database, and I'm using the here I want to see the generation from my solar system, and in the aggregate this aggregate table, I'm always calculating I'm always saving the latest day for the total generation. So that gives me the total generation for the actual day. So I can just easily run a select statement in this table with a from and to date from date and an end date of let's say today and today minus 30 days, and then just use the sum value of the SQL engine to add up all the values and then return me one single value as the result of the select statement. And so I'm issuing the exact select statement in both cases. The only difference is that in the first case, the from and end date is the last 30 days, and then for the second one, it's the 30 days before that. And I'm using the same methods as what I used for the chart. Is that I'm marking the last message with completed equals true, so it gets joined. The messages get joined together by this join one, which then treats the last message with a complete flag as treats the message with a complete flag as the last message. So this piece, the whole concept here is exactly the same what I've used here in the chart. And then finally I have this prep function node, which does all the calculations. So and here you can see that because my select statement is returning one single value, so the message payload 0 is the result of the first select statement, and it only returns, because I'm selecting a sum, it only returns one single record. So this is why the secondary is again with an index 0 and the value, and I divide it by 1000, so I get kilowatt hours at the end. It's like a smaller number to display, and I'm using the math floor to get rid of all the decimal places. I put a unit, and then I'm using the second data source, which is the second statement, to calculate the small value, so the 175 in this case. And again, I'm doing divide by 1000, and I'm using the math floor to get rid of the decimal places. And I compare the two values together to see if the trend is up and down. And as you can see, what I am passing through from this message structure, from this function node, is a specific structure. So the title is the title property is this one, which gets displayed on the top, and then you have the current property, which is the big value, the unit property, which is the unit, which gets displayed below that, and the reference is the small reference value, and there is a trend which either says up or down. And the data which is coming out from here, sorry, I missed the semicolon. So this message which comes out of here goes into a trend, which is a UI, what is it? Yeah, a UI template node. And so all I'm doing here is I'm just manually putting together a small HTML file which gets displayed here, and basically it's a very simple table. So I have a column up here which is a cell here which is 2 columns wide, which displays the text, and then I have a cell here which displays the big value and the unit, which is actually 2 rows high, and then a cell here which displays this arrow, and another cell here which displays this smaller value, and that's it. And you can see it pretty much here. So this is the first one, row span 2. Oh no, actually this is column span 2, so this is the title, that's where I'm putting the title in, and then this is that's where the big number is, and you can see that the current and a new line, and then the unit. Oops. And I tried to use so I use styles, so CSS styles in most cases, and I haven't made any changes to the font. So all I have done is I increased the font size, and I put bold or italic So you can see font size 300, font size 300, and in for the up and down arrow, use the color property to set it to green or red, and whether it's up or down, I'm just using these HTML tags which display the or HTML characters which display the up and the down arrow. And then finally, that's the small one. It's the there is no font size change, so it's the basic font size, and I just made it italic. So that's why you see it like this. So the current value gets displayed in big and bold, and the small value gets displayed in normal size and italic. So if you if you don't like this size format, so if you want this to be 6 wide, or even want to be smaller, so 3 wide, then I would recommend coming here in the template node and start playing around with these font size values, just to make sure that you can fit into the box. And of course, if you're planning to display something which is smaller values, it's always 1 or 2 digits, again you can increase the size so it looks a little bit bigger, and then maybe visually it just looks a little bit nicer. Or if you don't have units, just get rid of that, get rid of this one here, which is the new line and the unit part, because again that would create a new line, so that influences how the whole table is getting displayed. So it's not really complicated, but I think it's quite versatile, because if you want to use it multiple times, all you need to do is copy this whole block and paste it again, and then start playing around with the select statements here, and with, let's say, with the the from and to dates, and then that's it. You don't have to worry about any of the rest, because it just, as long as you can select supplies 2 statements, it would just calculate the differences, do the formatting, and the last one, the UI template, would just take care of the display, rendering that HTML code, which looks something like this. So simple as that. The second example is, again, it's almost the same. The only difference is that this value is being displayed as a percentage, and the select statement is, or that this function node looks exactly the same. I mean, now I did like -7 days because this one is showing the last 7 days and not last 30 days, but otherwise the logic is exactly the same. And here the value of the reference is calculated by the different logic, obviously, because I'm getting the exact same value. So the generation for the last 7 days, the last 7 days and the 7 days before that. So this line just calculates a normal percentage, divided 2 values together times 100, put the percentage mark, and then remove all the this floor removes all the decimal places, and this ABS just removes all the sign. So if it's going down, it still shows 51 instead of -51%. So the last box is a slightly bit different, because instead of comparing this value, the current value, to something else, I sort of know that I usually, if I have really sunny, it's again the solar panels. I'm using the solar panels as an example. I know that if I have a really nice day, I get about 20 kilowatt hours max. So what I said here is, I'm not going to, I made the logic a little bit simpler. So it's one single select statement, which is basically, again, using this aggregate table to look for the today values, today's sensor value, which is against the last value from the day, and actually it's going to be the last value from yesterday. And I'm using this the from date, just to make sure that it's the today 0 hours minus 1 day, because that's how that's the date I always put against the value. So anyway, you have a SQL statement which returns you one single value, and all I'm doing here is I'm generating the exact same structure. So I have a a title, I have a current value, I have a unit, and I have a reference, which reference is in a percentage format. But here, in the percentage calculation, even though instead of using a previous value and the current value, the previous value or the reference value is 20,000, which is 200 kilowatt hours. Sorry, 20 kilowatt hours. So again, you can combine, you can replace this logic with, with this percentage calculation logic, because at the end, the structure of the message that you are sending out is exactly the same. So you have a title, current, unit, reference values going out. You don't have up and down, because in this last particular one there are no up and down arrows. And this UI template will take care of the formatting. So the front of it looks exactly the same, and in here you see that I add another line in the table, which I'm giving this light gray background. So you have this gray line here. So it shows an indication, where this bar is going to, or is supposed to end at 100%. And you create two tables. The first one has a solid blue border, which is basically this one. So it's like instead of using the background, which for some reason doesn't get rendered, I'm using the border. And the width of the first cell is the reference, so that's the percentage. And then you have a second cell which doesn't have any background, and the width of that is 1 minus the percentage, and that's it. I hope that you find, well, not only the improved report, but also these, let's say, KPI functionality useful. Again, I tried to design this in a way that you can, with minimal changes, which mostly needs to be done here, you can replace and then, adapt it to your database structure and your values. And again, you can mix and match these trend boxes to control the appearance to be something either like this or something like this or something like that. And each of them expects the same input structure, which you can see here. So the title, current, unit, reference. And again, if you only like the look and feel of these boxes, but you want to do a completely different logic behind it, just remember to send the UI template a message which contains these values, and it would render it as you can see on this screen here. I hope you find it useful, and see you in the next video.